The strategy of eliminating possibilities is also used in logic type of problems. So here we're given some information. Saturday afternoon, Aaron, Boyd, Carol, and Donna stopped by the soda fountain for treats. Altogether, they ordered a chocolate malt, a strawberry milkshake, a banana split, and a double dip walnut ice cream cone. Given the following information, who had which treat? So we have a table here with the 4 names and then the 4 treats, and we're going to put X's if somebody does not match to a certain treat, and I'm going to do a check mark. You could also do a circle if it is the correct answer. So sometimes people will do X's and O's or X's and check marks. So the first bit of information we're given is that both boys dislike chocolate. So that means they are not interested in that chocolate malt. We're also told that Boyd is allergic to nuts, so Boyd is not going to be having the double dip walnut cone. Third one, Carol bought a malt and a milkshake for Donna and herself. So Carol and Donna are going to have the malt and the milkshake. That means they're not having the banana split and they're not having the double dip walnut cone. We also know if Carol and Donna are having the chocolate malt and the strawberry milkshake, that Aaron and Boyd are not having that strawberry milkshake. So without even getting to that last little bit of information, we're able to deduce what Aaron and Boyd got. The double dip walnut cone, the only person that's available to have the double dip walnut cone is Aaron. So I'm going to put a check mark there. And actually, I'll do it in a different color just to make it stand out even more. There we go. There's our check mark. So if Aaron had the double dip walnut cone, he did not have the banana split. So the only person to have the banana split is Boyd. So we are halfway done. Now let's look at Donna and Carol. It says Donna shared her treat with Boyd. Well, Boyd does not like chocolate, so he's probably not going to share a chocolate malt, but Boyd would share that strawberry milkshake. So that means Donna had the strawberry milkshake. And if she had the strawberry milkshake, that leaves the chocolate malt for Carol. And I can go in and fill in the other X's. So by eliminating possibilities, what is left is what the 4 kids had as their treats. Now there's one last strategy in this section. It's called the pigeonhole principle. And the name comes from the old-fashioned desks. I'm not going to draw a picture. You can Google search it. But think in your mind's eye about those old-fashioned desks that had all of those little tiny slots above them, like little square slots. Those are what we call the pigeonholes. And the way the pigeonhole principle works, let's say, for instance, that you have a real simple desk, and your desk has 4 slots in it, but you have 5 things. I'm going to represent them here by these 5 dots. Let's say you have 5 dots to put away into these 4 slots. The pigeonhole principle says, if I'm trying to fit these 5 things into these 4 slots, since 5 is bigger than 4, one of the boxes is going to have more than 1 item in it. There is no other way to fit these 5 items into 4 slots. That's the idea of the pigeonhole principle. And we can use applications of that when solving problems. So this example here says a student working in a tight space can barely reach a box containing 12 blue rulers and 12 red rulers. She cannot see into the box. How many rulers must she grab to ensure she has at least 2 of the same color? So in this case, if you want to think about, you've got 2 slots. You've got red and blue. So using the idea of the pigeonhole principle, to guarantee that she has 2 of the same color, and it really doesn't matter if they're 2 red or 2 blue, but to guarantee she has at least 2 of the same color, using this pigeonhole principle, she's going to need to grab 3 rulers. Because if she were to grab just 2 rulers, she could have 1 of each, but grabbing that 3rd ruler, that 3rd one is either going to be a second red or a second blue. So that guarantees that she has 2 rulers of the same color. So again, she's going to have to grab 3 rulers to guarantee that she has 2 of the same color, and again, based on the pigeonhole principle.